Hello, everybody. This is Douglas O'Clair. I'm the owner of the company Logical Graphs, and I'm known online as Joff. Today, we're going to be discussing graph theory and graph databases, particularly as it relates to cryptocurrency portfolio representations as ontologies, what that all means. I'm going to show you a working example up front, and then I'm going to show you how to create a graph database from first principles. And then how to navigate the graph database. I'll go through that as throughout this discussion. So graph databases. First of all, what's the point? The point is that one of my missions in life is to find ways to represent knowledge so that it's usable. And usable by whom? By you. The problem with information these days is that there's so much of it available out there that you may not know where to start or what to look for or how to parse out useful information from the noise. And so one way to help you, to guide you to make better decisions is to represent knowledge in a way that it is useful for you. And that's where I find graph databases shine. So let's get to it. So what we have here is a graph, is my repository of how I represent my portfolio as a graph database from first principles. First, let's take a look at the my representation of the blockchain. So you see here in my representation of the blockchain that I have a folder representing the blockiverse, the collection of blockchains, and then each of my blockchain portfolios. In Avalanche, Arbitrum, Optimism, Kujira, FBETH, Orca, Sumo, my Sumo Vault, Mensa, Terra, Cosmos, and Tron. And under one universal hood is my blockiverse, which represents every token and every blockchain and every protocol. So with that information, what I did was I coalesced it into a spreadsheet, and I have representations here that show my investments per blockchain. So you see here that I have this much available in Kujira, and then other blockchains. My second biggest one is Arbitrum. I have representations of the protocols in blockchains as a Venn diagram, and then I have representations of the tokens in the blockchains as a Venn diagram, and then I have the tokens in the blockchains with their amounts represented here. That's great. So those are various representations of a spreadsheet. The problem with these representations is that they're useful for their purpose, so that's a good thing. But the problem is that if you want to query into those data, it's hard to do it via these representations. They're static representations. So that's why we have the representation as a graph database. Graph database is comprised of nodes, for example, my portfolio, and relations, which connect nodes to each other. So, for example, here you see a representation of my portfolio as a set of blockchains connected to my portfolio. And then you can drill in and see in this data representation that I have protocols associated with Kujira, for example. And if I dig in further, in those protocols, I have tokens represented. So Kuji is part of my FBETH portfolio, as well as ETH and Bitcoin and stables. And so where else do I have an ETH invested? All I have to do is click and see. And then as you see, ETH is in, let's hide this one. ETH is in my ETH portfolio, of course, but it's also in my Indigo portfolio, which is in the Cardano blockchain. And it's also in Granary, which is in Optimism. And it's also in my Arbitrum portfolio in Arbitrum. So this is a very simple exploration of a graph database. I started with a simple node, and then I dug into what that node represents. And then if I'm curious to find out what the relation to this node is, I can dig further and say, okay, I'm looking at Terra now. And then I go into Lion, and I see Lion has, of course, Roar associated with it. Roar is also in my Sumo Vault, which is on the Kujira blockchain. So not only do I have a roundabout way of saying is not only do I have Roar in the Terra blockchain, but if you follow the path, it's also in the Kujira blockchain. No surprises, but that's good to know. That's one way to query a graph database visually. And props to Neo4j to making this visual interface so easy to do that anybody can grasp it very quickly. But there is more to querying a graph database than doing visual inquiries. The visual inquiry is perfectly fine, and you can discover knowledge by doing visual inquiries. And in fact, I hand graph databases to companies, and they discover knowledge simply by probing the graph database visually. They don't need to learn the programming language of the graph databases. And that's totally fine. But there are also other ways to explore the graph database. For example, you see in my portfolio that I have CoinMarketCap price quotes, and I have listed all the tokens that I query with the prices for that day. At the same time, I have all the tokens in my graph, in my portfolio across the blockiverse. So an interesting question to ask is, are all the tokens that I query against CoinMarketCap being used in my portfolio? Well, you could create a pivot spreadsheet if you're so inclined and query that information by creating more spreadsheets from the spreadsheets that you already have. That's one way to do it, by creating a pivot table. But now that I have this information encoded into a graph database, I can also query it via the graph database, because if you look at my graph database, you can also query the CoinMarketCap data. And you see that associated with CoinMarketCap is a set of tokens. So, like for example, if one token that I know I have is gold, right? Nope. According to CoinMarketCap and my portfolio, I don't have any gold invested. Why is that? Well, if we go back to my portfolio, and you can do this visually as well. You can query the graph visually to get to the portfolio. And we look in Kujira. Well, let's actually do a query. I'm looking for gold. So I have PaxG, and it's only associated with CoinMarketCap. Let's just add a little G in front of PaxG and see what happens. Look at that. I have an aliasing problem. Kujira blockchain for the longest time called PaxG, GPaxG for gravity bridged PaxG. Now they're calling it PaxG.grav. But for the longest time, it was GPAX-G. So when I queried my coin market cap, I had the mistaken assumption that I didn't have anything invested in PAX-G. Incorrect. But okay, so let's use an example where I know that I do have something, and that is Kuji. So let's zoom out. You see here that, let's look for my Kuji, that Kuji is a token being used, and it's being used in several of my investment instruments. It's being used in Orca, FBETH, Sumo, Kujira, Mensa, Blue, and Fin. So I'm using Kuji. I have an example that I'm not using PAX-G correctly in my spreadsheet, so that's something I need to correct. Why? Because I want to be able to query the assets that I have in a uniform way to say, okay, I'm investing in PAX-G. Here are the portfolios that here are the protocols that I'm investing in. Here's the blockchains that I'm investing in. Those kinds of things. So I want a uniformity of approach when I'm doing queries. But also I want to know, am I extracting information from CoinMarketCap that I don't use? So one way to ask this question is to say, are there tokens here that I'm querying in CoinMarketCap that don't exist in protocols on my block-averse portfolio? So how do we go about doing that query? Well, I actually built that information by creating a query folder. So if we look at my Cypher, which is the programming language for the graph database, you see that there's a query that says, query to see which tokens are recorded that I don't have anymore. So if I paste this query into my graph database and query it, then I get, these are the tokens that are not associated with anything. There's a couple of mistakes in there because I'm not properly recording information, for example, on my Indie. But I used to invest in Joe, I don't anymore. I used to invest in Juno, I don't anymore. I used to invest in KNC, I don't anymore. Matic, I was thinking, I did invest in Matic when I first started, but I don't anymore. PTP, Secret, SD, Stride, I actually do invest in. It's just a row that I forgot to add in. USDT, no, I don't have any more of that. Swift, I have some, but just a paltry amount. Curve, I lost all that on Phantom. So these are tokens that either I forgot to record. So that's a piece of knowledge that I gained by querying the graph database that, hey, these data I'm not covering, or that I'm not recording anymore, so I can remove from the list of tokens that I query against CoinMarketCap because I don't use those anymore, or they don't exist anymore. So that's one way to query the graph database. The other way to query the graph database is, for example, this is a query. Which tokens do I have and where am I investing in them? So I can see, for example, one token is in Harmony. Link, I have both on Kujira and on Harmony. Had some on Phantom, but that was lost. Kujira, you see that it's all in the Kujira ecosystem. Atom, all Kujira. Dot, all Kujira. BNB, all Kujira. Lido's token is an optimism. The optimism token itself is also an optimism. And you see on and on and on that for example, ETH is spread across multiple blockchains. Got Kujira, Optimism, Arbitrum, and Cardano. Avax is an Avalanche, of course. So you can see where I'm deploying my assets, what assets those are, and in which blockchains by doing queries against the graph database. So if I run this query, it comes up a list and shows which tokens I have and where they are. I can also do things like so for example, if we look at tokens in particular, just picking up 3 tokens at random. If I connect, let's go with Link. You see that Link, let's hide this one. Link is in AAVE, currently locked because it's on Harmony 1, and in Orca. But if you hover over the relation between these 2 nodes, you see that there is a relation. And when I highlight that relation, you see that if you look at the right-hand corner, that it is in the Kujira blockchain, and its value is 1.995. And value is, I'm representing in dollar amounts. I choose to represent in dollar amounts. So what you can do is say, okay, what are all the tokens in Orca? I'm curious. So if I match, one way to do that is to do the visual query, and you see the tokens. Another way to do that is to use the Cypher query language and say match P protocol, where the name is Orca, and it's associated to a token. Okay, so give me all the tokens that are associated with Orca. And it lists out the tokens. There you go. But the relation itself has information. So if I query the relation, I'm just going to blind query that relation. I can get the name, and I can also get information about that relation. And so you see, I have almost $2 worth of Link in my Orchid portfolio. I have $1,300 worth of Kuji in that portfolio, $373 worth of Luna in that portfolio, et cetera, et cetera, et cetera. Well, then I can go a step further and say, how much is Orca worth altogether? And Orca is worth $4,600. I can also do other things like match me a blockchain associated with the protocol, and then the rest of the relations are the same. And then I say, give me the blockchain. And then also give me the protocol. And then also give me the amount of money in that protocol. And you see, I just queried Orca, so it tells me that in Kujira, Orca is worth $4,000. But if I release the constraint here, I see all the blockchains and all their protocols with all their total values associated with those protocols. If I want to query a specific blockchain, let's say Avalanche. Then I see all the protocols that are in Avalanche and all their values. But if I don't care what the protocols are, then I can just simply remove this. And let's see what happens with this query. And it shows me the total amount in Avalanche. I have $44,000 total value in Avalanche. How much do I have in Jira? 57,000. So one way to query is using the programming language Cypher when you're using Neo4j as your knowledge representation. The other is to use the graph as a query language itself. So I can do something like this. Return the set of relations and change that into a graph view. And then boom, this is everything that I have associated with Kujira represented as a knowledge graph. And so, and then if this information is too complex, I already looked at Orca, so let's hide the Orca information. Boom. So then I can just focus in on these other protocols as necessary. Let's say I want to look at just Manta. Then we see that I have Manta in Manta. And if when I hover over it, look at the right-hand side, I see I have $900 worth of Manta in Manta on the Kujira blockchain. Pretty neat. So couple of use cases. One is making your portfolio more efficient and effective. So the earlier example I ran through, I showed that I was extracting information from CoinMarketCap, some information I don't need to extract. Another way to use this representation is that I can explore my investments in my portfolio by point and click. I say, okay, I want to look at the Kujira blockchain, and behold, let's hide this one. All the protocols come up. I want to look further into Mensa. What's that? And it shows me in Mensa, I'm investing in LPs and I'm investing in particular tokens. Where else am I investing in stables? Well, then that shows me further, let's zoom out here, that I have stables invested in Sun, which is in which blockchain? It's in the Tron blockchain with the Sun token. And I also have in Ghost and Indigo and Granary Finance, Granary, particularly on Optimism blockchain. So this allows me to say, where are my stables at? And boom, everywhere that stables are mentioned, I get references pointing me to the protocols, and then I can dig further and I can say, okay, which blockchains are those on? Another way to do a representation is if I want to be token focused centric, I can query starting from tokens. If I want to be protocol focused, then I can start queries from protocols. If I want to be blockchain focused, I can start queries by starting from the blockchain. So let's say I want to be token focused. So I'm looking at 3 different tokens. Where's my Kuji at? And it shows me Kuji is in these protocols. Also, it's listed on CoinMarketCap. Um, and, um, and since I was also looking at Link and One, it shows that those two are also on CoinMarketCap, and Link is also in Orca. So I'm like, okay, I can do interesting things with relations, like give me a token that's associated with another token via a protocol. That's a query that you can write in Cypher. Match T1 token that's associated to a protocol, and associated with that protocol is another token. Okay, let's look at the query. Okay, I see what the problem is here. Um, let's see if I can do this. Oh, it's not a protocol, Dwight. It's not a relation. Protocols are objects or nodes. So let's do this. Correct the syntax error. And then behold, I have places where I'm investing ETH and Kujira, Bitcoin and Kujira, stable and Kujira, et cetera, et cetera, et cetera, et cetera. So if I want to focus on relations between tokens, I can do that by querying the graph database. If I want to focus on particular protocols, I can do that in the graph database. If I want to focus on particular blockchains, I can do that with the graph database. And I can also look at it in a graphical representation. And you see graphically that we have lots of interesting relations where, for example, if we just zoom in really closely on this one here, Cardano has both ADA and Snake related to it. Now we zoom back out. Let's look over here. And then we're looking at GMAX, has GMAX, GLP, and AVAX associated with it. I have a long position on AVAX. And then you get to see a lot of interconnected, interesting relations here. Let's zoom in really closely here. Like, for example, Fin, there's a lot of different tokens associated with Fin and with Orca and with my Kujira wallet. Sumo Vault has a bunch of tokens associated with it. So you also get densities, like which protocols have multiple tokens associated with them, which protocols have few tokens associated with them, which protocols are interconnected by tokens, for example. Like for here, ETH connects a bunch of different protocols across multiple blockchains because I'm interested in Ethereum as an investment token, not the blockchain. So this is a way of representing knowledge that is different than representing knowledge by spreadsheets, which are my specialty, and data visualizations with static representations, such as with Venn diagrams, with pie charts, or with other charting tools, bar charts and other representations. For example, a hierarchical charts. The static representations give you a good snapshot of the data at one point in time or with one particular perspective. Using a graph database, you can take a more interactive approach, query the graph database, and then start to discover and explore knowledge, representation, and relations between various areas that you're interested in. This particular repository is a repository that I created called Ont for ontology. It's in my GitHub repository, and I'll be sharing the information on this particular tool. What Ont does is that you put in your spreadsheet as a tab, separated value input on the input stream, and then you pipe it through to Ont. Ont then generates the appropriate cipher that represents your graph database representing your portfolio. It clears the graph database, creates the portfolio, creates the blockchains associated with that portfolio, and then creates the relations between protocols, tokens, and then eventually blockchains and protocols, and then matches the blockchains to the protocols and links them together. With this information where you associate the token to the protocol and highlight in the relation itself, first, the value of that token on that protocol and the blockchain that token is in on that protocol. You can do all sorts of interesting queries into that graph database to see or to discover information that would be not straightforward to discover on a spreadsheet. And then that's one layer. Another layer is that you can start layering aspects of knowledge or information or representation on top of this basis, because this basis is protocols, tokens, and blockchains with the values of the tokens and the protocols on their blockchains. What if you want to layer in an aspect of, say, let's go to a particular blockchain, that you want to know which tokens are being used for supply, which tokens are being used for leverage, which tokens are being staked, which tokens are being used for arbitrage. If you capture that information as a graph, you have that associated to your tokens, then you can overlay a graph on top of a graph, and then you have a multi-dimensional graph on which you can query to say, okay, what is my staked position? What are the tokens that are staked? What are the value of the stake? Okay, now let's look at leverage. Now let's look at arbitrage. Now let's look at holding positions. Those different things. By overlaying knowledge on top of knowledge, you have more depth that you can query into, more questions that you can ask, and more ways to see your way into what's working for you and what's not, so you can increase the efficiency by which you can become profitable. I'll put the links for this ontology generator into the video description. Thank you so much.